We've learned about extrema before. Let's briefly review it. Extrema refer to the points in the domain of a function where the function reaches its highest or lowest values. In the mathematical context, extrema are often referred to as maxima and minima. Extreme value theorem. It states that if a function f is continuous on a closed interval from a to b, then f has both a minimum and a maximum on the interval. Extrema come in two types. Global maximum, minimum. These are points where the function takes the highest or lowest values over the entire domain. On the graph, global minimum occurs at x equals a, and global maximum occurs at x equals d. Let f be defined on an interval I containing c. F, c, is minimum if f, c, is less than or equal to f, x, for all x on the interval, and f, c, is maximum if f, c, is greater than or equal to f, x, for all x on the interval. Local maximum, minimum. These are points where the function takes the highest or lowest values in the vicinity of that point. On the graph, local minima occur at x equals c and e, and local maxima occur at x equals b and d. The condition f prime of x equals 0 is useful for finding local minimum and maximum, but they can also occur at points where f prime of x does not exist. For example, f, x, equals absolute value of x. On the graph, f prime of x does not exist, but there exists local minimum at x equals 0. Interior points where maxima and minima occur, not endpoints, must be considered, as well as the endpoints. Let's examine the critical points. Critical points are the points in the domain of a function where the derivative is 0 or undefined. Mathematically, f prime of x is 0 or undefined. Let's examine the derivative test for extrema. 1. First derivative test. Analyzing the sign changes of the derivative around critical points to determine local maxima or minima. First, we find the critical points by solving f prime of x equals 0. Then, check the sign of f prime of x to the left and right of each critical point. If f prime of x is greater than 0 on the left and less than 0 on the right, it indicates a local maximum. If the signs are opposite, it indicates a local minimum. If there's no sign change, the point doesn't represent a maximum or minimum but a point where the slope doesn't change. 2. Second derivative test. Using the second derivative to check the concavity at critical points. First, we find the critical points by solving f prime of x is 0. Then compute the value of the second derivative f double prime of x at these points. If f double prime of x is greater than 0 at a critical point, it signifies the function is concave upward, indicating a local minimum. If f double prime of x is less than 0 at a critical point, it signifies the function is concave downward, indicating a local maximum. If f double prime of x is 0, the test doesn't provide a conclusive result. In such cases, you can use the first derivative test. Let's examine the following example. Find the maximum and minimum values of the function f, x, equals x minus 2 sine, x, on the closed interval from 0 to 2 pi. The function f, x, is continuous on the closed interval. The derivative f prime of x equals 1 minus 2 cosine x. It should be that f prime of x equals 0, thus, cosine x equals 1/2, which occurs at x equals pi over 3 or x equals 5 pi over 3. The second derivative, f double prime of x, equals 2 sine x, when evaluated at x equals pi over 3 and 5 pi over 3, yields f double prime of pi over 3 equals 2 sine pi over 3, it becomes square root of 3, which is greater than 0. Therefore, using the second derivative test, this qualifies as a local minimum. F double prime of 5 pi over 3 equals 2 sine 5 pi over 3. It becomes negative square root of 3, which is less than 0. Therefore, using the second derivative test, this qualifies as a local maximum. The values of f at these critical points are as follows. F of pi over 3 equals pi over 3 minus 2 sine pi over 3 equals pi over 3 minus square root of 3. It is approximately negative 0.6849. F of 5 pi over 3 equals 5 pi over 3 minus 2 sine 5 pi over 3 equals 5 pi over 3 plus square root of 3. And it is about 6.9680. Moreover, at the endpoints of the given interval, the function values are f 0 equals 0 and f 2 pi equals 2 pi. By comparing these four values within the closed interval, it can be determined the minimum value and the maximum value. When graphed, you can visually identify the presence of local minimum and local maximum points. See you next time.